Welcome you all. Today we will discuss about the Himalaya, just introductory part about the Himalaya, how it forms, what are the structures present in the Himalaya, what is the in- stratigraphy of the Himalaya, where it extend and up to where it extend, what are the structure bounded from the northern boundary, southern boundary, eastern and western, what is the longitudinal division, strike divisional of the Himalaya, what is the structural division of the Himalaya, what is the stratigraphical division of the Himalaya. All the aspects will cover this presentation today, and I hope you will enjoy this presentation. So in this lecture we will divide whole the lecture into three parts in Himalayan range, Himalayan organ and Himalayan tectonic setting. Himalayan range basically it's the extension of the Himalayan range from northwest from Pakistan to Burma, and it's include all the region from Pakistan to Burma along the strike up to Tipton Plateau. Okay, then Himalayan organ. In this, here one word we are using right now, that is organ. Organ means the uplifted portion due to the collision of two plates. So here we use organ because this Himalaya is the uplifted portion here due to the movement of the Indian plate and the Eurasian plate. Himalayan tectonic system. Actually, Himalaya has lots of structures, thrust, normal folds, strike slip fold, transverse folds in different units. So that's why this whole system is known as Himalayan tectonic system. So let's start Himalayan range. So Himalayan range is basically, we can divide Himalayan range from northwest to northeast, and it's laying between Namcha Barwa Parvat to Namcha Barwa Parvat in the eastern part and Nanga Parvat in the western part. The northern boundary is marked by Yalusangpo river that's flow along the strike of the Himalaya, and it's entered in the Indian territory through Arunachal Pradesh, and that is known as Brahmaputra river. The southern boundary is marked by the main frontal thrust. Main frontal thrust basically divide the this green portion is basically Indo-Gangetic plain, and this yellow part one is the sub-Himalaya, or we can say this is the Sivalik, as we know very well. So this is the southern boundary of the Himalaya. Then west, this western part is basically marked by Hindu Kush, and the eastern part is Indo-Burmese range, that is also known as Ronglang range. So Ronglang range. And the northern Karakoram mountain and the Ganges San, also known as the Trans Himalaya. That is the Trans Himalaya. Then Himalayan organ. Yes, one more aspect I want to conclude in this Himalayan range. This Himalaya is basically formed due to the collision of Indian plate and the Eurasian plate. Indian plates started moving towards the northeast direction when 200 million years ago, when Indian subcontinent break from the Pangaea and started towards the northeast direction. So this is important question, and it can be asked in many examination. That's what is the movement direction of the Indian plate. So in what was the movement direction of Indian plate during the collision of the Indian plate and the Eurasian plate. So Indian plate direction, movement direction was northeast direction, and due to that collision Himalaya evolved here or formed here. So in initial condition, Himalaya was the product of continent and ocean collision, because 200 million years ago there was an ocean that was known as Tethys Sea. But right now, due present situation is this is the product of continent and continent collision. So some people can ask, why you are saying Himalaya is a continent collision product? Because present is a continent collision. In past, there was a collision between ocean and the continents. So in the initial stage, that Himalaya was a continent-ocean collision product or we can say started from in continent and ocean collision, but ended at the continent collision. And we can say it's not ended, it's still rising. Okay, then Himalayan organ. So Himalayan organ actually, as I have already told you, organ is the uplifted portion. Organ is the uplifted portion due to the collision of two plates. So in the northern portion is demarcated by Indo-Sanko-Future zone. Indo-Sanko-Future zone mark the boundary between Eurasian plate and the Indian plates. Always remember, Indian Sanko-Future zone is a structure that separates the Eurasian plate to the Indian plate. Then southern portion divided by main frontal thrust, as I have already discussed. Main frontal thrust, that's also known as Himalayan frontal thrust and also known as Himalayan frontal fold. Okay, then the western portion is marked by Chaman fold. Chaman fold is a left slip fold. It's a left slip fold, and the eastern portion is demarcated by the Sagyong fold. Sagyong fold is the right slip fold. Okay, the Himalayan organ extends from Arabian Sea to the Bay of Bengal, as we can see. The the extension of the Himalaya is approximately 2300 kilometer, and the width varies from 140 to 240 kilometer. But whole organ extend from Arabian Sea to the Bay of Bengal, or we can say half of western area and half of eastern area and northern area has been covered by this Himalayan organ in the Indian subcontinent. Then Himalayan tectonic system. In Himalayan tectonic system, we can define that Himalaya is the combination of the Indo-Gangetic Plain, active Himalayan foreland basin, and Indus-Bengal fan. So there is lots of structures in Himalaya. So in Himalaya, we have lots of strike slip structures, though divide in different units. We can see in this division, this is the structural division. So in the southernmost portion, as we have discussed already, this is the Indo-Sanko-Future zone. Towards the southern portion, we have another structure. So this division is basically on the structure. So from north to south, we can mark these structure from north to south. STD, Southern Tibetan Detachment. Southern Tibetan Detachment is a structure that separates from Tethys Himalaya to higher Himalaya crystalline. Then we have MCT, Main Central Thrust. Main Central Thrust separate higher Himalayan crystalline to the lesser Himalaya. Then we have Main Boundary Thrust. Main Boundary Thrust separate sub-Himalaya or Shivalik to the lesser Himalaya. Then we have Main Frontal Thrust or Himalayan Frontal Thrust or Himalayan Frontal Fold that separate Indo-Gangetic Plain to the sub-Himalaya. Let's talk about the age of these structures. STD and MCT was formed at the same time. We will discuss further too. So STD and MCT both were formed at the same time during 20 to 23 million year in the western portion of the Himalaya and in the central portion of the Himalaya. The age of these structure is new towards the eastern Himalaya. I will discuss in as we can see here. So this is Southern Tibetan Detachment, 21 to 19 million year. This table actually is a long strike variation of timing, magnitude, structural style, and metamorphic condition across the Himalaya. So here we can see South Tibetan Detachment. This South Tibet Detachment, also known as Trans-Himadri Fault, and this structure is the only normal fault in Himalaya. This is a normal fault. This is not a thrust. All MCT, MBT, HFT, HFF, all are thrust, but this South Tibetan Detachment or Trans-Himadri Fault, this is also known as Trans-Himadri Fault. This is the only normal structure in Himalaya, and this is the age of this 21 to 90 million year, and here this is the main central thrust 21 to 90 million year. So the age of both the structure in Western Himalaya is same, that is known as oval thrust. Same thing in Central Himalaya, 23 to 30 million, 13 million year, 23 to 20 million year. So these are the oval thrust. As we can see here, in the Eastern Himalaya, the age is very young, 12 million year. So the collision date is younging from Western Himalaya to Eastern Himalaya. Same as we discuss about the MBT. MBT, the age of the formation of the MBT, we can see here that is 10 plus minus 2 million year. In Western Himalaya, the age of MBT, main boundary thrust, is 11 million year. In the Central Himalaya, 10 to 12 million year, and in Eastern Himalaya, again it's younging. This is less than 5 million year. Then if we go for the temperature, we can see the Eclogite terrain peak metamorphism found in Western Himalaya, as we can see, that's reach up to 720 25 degrees centigrade. It's slightly high in Central Himalaya, and no eclogite phase has been recognized in the Eastern Himalaya. So it's a very important question. Where is eclogite terrain missing in Himalaya? So answer is Eastern Himalaya, we can say. Then great counter thrust. Okay. Then we move in Northern Himalaya antiform, Somurari Dome. In Central Himalaya, Kangmar Dome, and in Eastern Himalaya, Yalaksangu Dome. So we can give the example of the dome too. Then Tethen Himalaya fold thrust, as the name and the age is in the Western Himalayas 56 to 46 million year, then 50 million year in unknown. Greater Himalayan crystalline peak metamorphism up to 680 degrees centigrade, in Central Himalaya 700 degrees centigrade, and in Eastern Himalaya up to 800 degrees centigrade. Why this is so? Because this Eastern Himalaya is very means we can say this is uplifting very quickly and exhuming, we can say. So the over underlying rock are exhuming very rapidly. Inverted metamorphic zone, inverted in Janskar. Inverted metamorphism, pressure and temperature conditions also exist in Central Himalaya, and but in Eastern Himalaya it's not measurable. Not yet we can say recognized. Okay, so in Lesser Himalaya, actually, okay, then so then come to the HFT. HFT is the or MFT is the recent formation, so it's going on, still going on. Then come to the litho and chronostratigraphic division of the Himalaya. So litho and chronostratigraphically we can divide into 5 parts from base to the top. This is the younging direction, this is the oldest direction. So the base is Phanerozoic cover sequence above the lesser Himalayan sequence, that is 520 to 20 million year. Then we have Tethys Himalayan sequence, late Precambrian to Eocene, and in Tethyan Himalayan sequence we get sedimentary rock and some metamorphic rock too. And yes, we have some interlayered volcanic activity flows. Then we have Greater Himalayan crystalline. Greater Himalayan crystalline reach up the age is 800 to 480 million year, and yes, in Greater Himalayan crystalline is also known as Higher Himalayan crystalline, and in Higher Himalayan crystalline we have tertiary intrusion of granite too. Lesser Himalayan sequence, we can divide Lesser Himalayan sequence into 2 parts. One is Lesser Himalayan metasedimentary sequence, another one is Lesser Himalayan crystalline sequence. So lesser Himalayan metasedimentary sequence is basically laying below the lesser Himalayan crystalline sequence. So these lesser Himalayan crystalline sequence occurred in the form of nappes and clippes over the lesser Himalayan sequence. For example, Almora clippe or Almora nappe, Kathmandu nappe, and these windows also, some windows also exist like Paro window in Bhutan, Rampur window in Himachal Pradesh. All these are the example of lesser Himalayan crystalline or the lesser Himalaya. Then we have Shivalik group. Shivalik group also known as sub Himalaya, and this the main lithology of the Shivalik group is sandstone, clay stone, and some boulder beds, and these belong to Neogene is 22 20 to 2 million year is. Okay, we will discuss distribution also. Then we have map view. If we divide based on the map view the Himalaya, then we can divide into following division. The northern portion is the northernmost portion is the Tipton Plateau. Then we have Yalu Sangpo River in the center portion, and towards the eastern portion Indus River towards the western portion. Then we have North Himalaya, Himalayan crest, then we have higher Himalayan base of the northernmost steppe slope, then we have lower Himalaya, then sub Himalaya. Then if we divide the Himalaya into vertical division or based on the elevation, then we can divide basal Himalaya 50 to 1500 meter elevations peaks comes under this. Middle Himalaya 1500 to 3500 meter elevated peaks. Upper Himalaya more than 3500 meter elevation. Along strike division we can divide Western Himalaya, Central Himalaya and Eastern Himalaya. Western Himalaya include the part of Kashmir, Janskar, Spiti, Himachal Pradesh, Garhwal and Kumaon. Central Himalaya basically Nepal, Sikkim, South Central Tibet, and Eastern Bhutan, Arunachal Pradesh and Southwest Tibet. So this table we have already discussed. So this is the temporal division. So from this portion to this portion somewhere here, this is the Kumaon region, or we can say this is the Uttarakhand state of the India country. So here this is the boundary of the Kumaon region and the Nepal region. So from this point to this point, this whole region comes under Western Himalaya. From here to Sikkim, this is the Sikkim. From C point to E point, this whole region comes under Central Himalaya, and E point to whole region up to this point, these all known as Eastern Himalaya. So this is the strike along the strike division. Now in this map is basically after Engine 2006. So you can get this geological map from that research paper. So these are the some major lithology in the Himalayan. So this is the GCT, Great Counter Thrust. This one is the Great Counter Thrust here. So this is Great Counter Thrust. Then we have Indo-Sangpo Milan Zone. So this is the Indo-Sangpo Milan Zone here somewhere. This is Indo-Sangpo Milan Zone. Then we have Tethyan Himalayan Sequence. Tethyan Himalayan Sequence. This is the Tethyan Himalayan Sequence here. Then we have South Tibetan Detachment or Trans-Himadri Fault. This is South STDS we can see, and throughout the Himalaya this is following this line. This is Tethys Himalaya, and this pinkish color, this one is the Greater Himalaya or Higher Himalayan crystalline throughout the Himalayan region. Okay, then we have Lesser Himalayan Sequence. As I have already told, Lesser Himalaya further divided into two parts. So then we have MBT. So we can see the location of the MBT here. This is MCT. Then this is MBT. This is MBT. So MBT mark the boundary between Lesser Himalaya. These are the this is the Almora Nape, or this is known as Garhwal Nape also. Then these crystalline rocks over the Lesser Himalaya. These are the Lesser Himalayan crystalline rock formed in the form of napes and clippes. Okay. Then we have sub-Himalayan sequence. This one is the sub-Himalayan sequence. So this sub-Himalayan sequence is also known as sub-Himalaya or Shivalik also. Okay. So this is the Himalayan tectonic models. So Himalayan tectonic models we can discuss after Brookfield and Redden, Gurjik et al. And Kohn. Northward tapering wedge extruding south between two lower grade sequences. So if we move from Miocene to Miocene, as we can see, so these sequences, these discuss that main central thrust. This is the MCT and this one is the southern STD. So between STD and MCT, we have this one, semi-molten material that's evolved over the surface. Why evolved here? It's evolved due to erosional activity, as we can see here. During this time, this molten material comes up and stagnant up to here. So these fault created here simultaneously. But due to erosional activity and development activity, this old Tethys Himalayan sequence eroded away and this greater Himalayan crystalline exposed over the surface. So the steady kinematics may be driven by rotational or principal stresses along the topographic front that generate upper crust extension along the range crest or may represent adjustment to the maintained critical point. The GHC represent a partial molten lower middle crust in the thickened collision zone that tunnels southwards driven by the gravitational potential. So this STD and main MCT provide a tunnel shape type of structure. That's why GHC comes up over the surface. This material channel, or this is also known as channel flow. So this channel exhumed between active fault by erosion across the narrow zone, we have already discussed. The initiation of rapid exhumation or paired channel flow focused denudation system is speculated to result from a precipitation increase associated with a climatic shift. Top knot motion along the steady does not represent extension. Actually, when we move towards the northern portion, so here the shearing direction is top to northwest. So this Brookfield and this model is saying that this one is not the extension, but this is the 10 kilometers of back thrusting in the MCT hanging wall. The top northern displacement is kinematic linked to the north-directed great counter thrust, which juxtapose the Trans-Himalayan sequence or Tethys Himalayan sequence rock atop the Asian plate rock and suture zone rock to the north and was active in the early middle Miocene. So this is the Himalayan tectonic models along these resources. I hope you will enjoy this lecture. Thank you very much. Please share and subscribe this channel. I hope I will be back to you with a new lecture.